Okay, so let's dive into this really cool story of innovation, efficiency, and some serious real world impact happening within a government research project. It's a fantastic example of how just one dedicated support scientist can become a force multiplier for the public good, saving water and, a whole lot of taxpayer money.
So, how does one person pull all this off? It really starts by tackling this huge challenge that they're facing in the American Southwest. And the solution is this unique mix of super high tech science and some seriously old fashioned get your hands dirty hard work.
The mission here is pretty clear. Develop sustainable turfgrass systems. We're talking grass for parks, sports fields, public spaces that can not only survive, but actually thrive in these really dry climates. The idea is to use way less water, cost less to maintain, and at the same time support American industry. Let's start with the cutting edge, high tech side of the job. And honestly, this looks way more like a data lab than it does a farm field. This is where modern science gets incredibly powerful. So, instead of just walking around and looking at plants with a clipboard, this scientist actually built a custom system to analyze a massive amount of visual data. It literally transforms thousands of simple digital pictures into hard, scientific insights about how healthy the plants are, their color, and how they're handling stress. And get this, 5,400. That's the number of images that were collected in just 1 week to get a handle on the field experiments. It's this sheer volume of data that makes the whole AI-driven approach so incredibly powerful. And there's a name for this method, high-throughput phenotyping. It's a mouthful, I know, but it basically replaces the slow, kind of subjective, manual way of scoring things with this automated, data-driven analysis. It lets scientists evaluate hundreds of different plant varieties way faster and more objectively than ever before. And this chart just brilliantly illustrates the power of that analysis. By creating custom machine learning models to calibrate the soil moisture sensors, the accuracy of the data just jumped, dramatically. We're talking about going from a score of 0.26 all the way up to an incredible 0.98. That is a game-changing improvement in data quality. But here's the thing, and this is so important. All of this advanced data science is built on a foundation of gritty, physically demanding fieldwork. You just can't get good data without getting your hands dirty. This is a direct quote from the scientist's own work logs, and it really highlights a core truth of this whole project. Any progress made in the lab is completely impossible without total dedication out in the field. And this is not just about running code. A typical day could mean anything from moving over 500 pounds of rocks to operating heavy machinery to pulling weeds by hand for hours under the hot sun. It's really about doing whatever it takes to make sure those experiments are set up perfectly and meticulously maintained. $2,100. That's the cost of a single new high-value soil moisture probe. These things are absolutely critical for the research, but man, they are expensive. So, instead of just buying a bunch of new ones, this scientist went out, literally dug up, cleaned, and refurbished dozens of used probes from old experiments. This simple, resourceful act saved thousands of taxpayer dollars and kept the entire project moving forward without any extra spending. It's just smart. Okay, so how do these two worlds, the data scientist crunching numbers in the lab and the field expert digging up sensors, how do they come together to create real tangible value? Well, all that data collected in the field and analyzed in the lab was used to create this simple but really powerful decision support tool. As you can see here, it shows land managers how to balance their inputs. For example, it proved that if you apply fertilizer at just the right time, you can actually reduce water use while keeping the same quality, which directly lowers operating costs. And this work, it doesn't just stay in a lab. It has a real economic ripple effect. We're talking about supporting jobs in the multi-billion-dollar American turf industry, helping cities and golf courses save money, and protecting the public's investment in research by making sure the data is rock solid. This unique combination of skills and just sheer dedication, it provides a powerful blueprint for the future of public research. It shows us how we can get the absolute most value out of every single tax dollar. This brings us to this core concept, full-stack scientific capability. Now, it sounds a little techy, right? But what it really means is bridging the gap between technician and scientist. By combining all these different roles into one, this model gets rid of delays and becomes a true force multiplier, maximizing what you can get done for every dollar spent. So you can really see the shift here. We're moving away from that slower, more expensive model where everyone's in their own little silo towards one that's integrated, resourceful, and just incredibly efficient. It's just a smarter way of doing science.
Ultimately, when you boil it all down, this is a story about stewardship. It shows how modern agricultural science, when it's driven by one person's initiative, can solve huge real-world problems by saving water, saving money, and supporting American jobs.
This single example proves that a real commitment to both high-tech innovation and that hands-on diligence can create exceptional value for the nation. It really leaves you wondering, right? What other massive problems could we solve if we just applied this same resourceful full-stack approach?